Come to the discussions of the past year questions. This video we shall discuss about the further pure mathematics 2, May June 2024, paper 21. Let's take a look at the first question. Find the roots of the equations of z cubed equals to the negative 108z3 plus 108i, giving your answer in the form of a trigonometric form, where the r is positive and the data is between 0 to 2 pi. So for this question, first of all, we need to convert this this complex number into the trigonometric form. Okay, so for this, usually we can just factorize the 216 out, make this become negative 3 over 2 plus the half I. Okay, so from here, you know that this is actually at the x is negative, the y is positive. So you are actually at the second quadrant. So from here, you can see that your r is a 1 and your angle theta, it will be this. Actually, you can just use your calculator. You can see that actually this one is cos of 150 degree. This one is actually sine of 150 degree. However, we will going to write them in radian. So we just change this to become cos of 5 pi over 6 plus the I sine of 5 pi over 6. Okay, so first of all, you change this to become trigonometry form. After you have changed into trigo form, then you can find the z. Then it means you just put the cube root, put the cube root, go to the other side. Like this. Power 1 over 3. Okay, so by using the formula, you can write this one down as a 216 power 1 over 3. And you have a cos of 5 pi over 6 plus 2 pi k over 3 plus the I sine of 5 pi over 6 plus 2 pi k over 3, where your k is a 0, 1, and then 2. Okay, so if you put k equal to 0 inside, you get the z0 is equals to the 6 cos. Just replace k equal to 0. Just put all the k here become 0. And then after that, change all the k become 1, change all the k become 2 accordingly. So you will get z0. This one is a cos of 5 pi over 8, 5 pi over 18 plus I sine 5 pi over 18. Then z1 and z2. Do the same thing for the remaining two. Also, just use your calculator. You will get this one as a 17 pi over 18 plus the I sine 17 pi over 18. Then the last one, it will be 6 of cos 29 pi over 18 plus the I sine 29 pi over 18. Done. That will be the answer for the question number 1. However, you can see that I am using this notation. Okay, k is from 0 to 1. So if we follow the k, then the k will start from z0, z1, z2. But in the mark scheme, they will write it as a z1, z2, z3, which is fine actually. Okay, so it's up to you to decide whether you want to put z1, z2, z3 or z0, z1, z2. Okay, so without any confusion, I will put z0, z1, and z2. So that's it. Now we move on to the question number 2. Okay, Now we take a look at question number 2, the Maclaurin series for this up to and including in terms of x squared. So for these questions, we need to use the differentiations in order to find the Maclaurin series. First of all, you let this expression as a function of fx. So what you can see is that we just need to differentiate all of them. So this one is 2x e power 1 plus x squared. This one differentiate. Then differentiate it one more time. You just need to differentiate 2 times because they until x squared. So just need to do the second order of the derivative will do. But this time, the second order, it will need to do a bit more job over here to be done. So over here, just keep the left, differentiate the right, plus keep the right, differentiate the left. This one you get e power 1 minus x. Okay, so if you combine them together, you will get this as the 4x e power 1 plus x squared plus 2e power 1 plus x squared plus the e power 1 minus x. Now we just need to substitute the 0 inside the f. You will get e power 1 plus e power 1, you get a 2e. Then put the 0 into the first prime. You will get a 0 plus a e. So you get a e. Then the second prime, if you put 0, you will get 0 plus 2e plus e. At the end, you get 3e. Okay, so this is what we have for the f0, f prime 0, and f second prime 0. So your Maclaurin series is actually equals to the f0 plus f prime 0x plus f double prime 0 x squared over 2 factorial and so on and so on. Okay, so we just put in the value. This one is a 2e, this one is a ex, this one as a 3e over 2 of x squared, just like that. Okay, so therefore your e power 1 plus x squared plus e power 1 minus x is equals to this expression. That will be the answer for the question number 2. Now we move on to the question number 3. Okay, now we take a look at question number 3. It is given that the x is equal to the arc sine of t and y is equal to the t arc cos of t. So the t is between 0 to 1, including 0, but not including 1. So the questions, first part, they ask you to find the dy dx. So this is a parametric equations. We just need to differentiate x with respect to t and y with respect to t separately. So this one, just use the formula. And your dy dt, chain rule, keep the left, differentiate the right, plus keep the right, differentiate the left. So you get this. This is a negative. So you can just check your formula booklet, MF19, and you can get this. So your dy dx is actually dy dt over the dt over the dx dt. So which means is cos of t minus a t over the square root of 1 minus t squared divided by the 1 over 1 minus t squared. So if you expand and simplify, you will get this one as the square root of 1 minus t squared. Okay, this one you get square root of 1 minus t squared cos of t minus a t. Okay, that is my dy dx. Done for the part A. Then we're moving on to the part B. Second order derivative. Second order derivative is a d square y ds square. That will be a d dx of the dy dx. So it will be your dy dx just now in part A is already in the form of t, in the expression in terms of t. So this one, it will be part A result, 1 minus t squared up cos of t minus the t. Okay, correct. Okay, so this one is in terms of t, this one is in terms of x. They cannot be differentiated unless you make it become d dt, and then you multiply by the dt dx using the chain rule. So over here now, we can solve it by using the chain rule. This part over here, we will just differentiate with respect to t as usual. So this one, we have keep the left, differentiate the right, plus keep the right, differentiate the left. Oh, no, please. So sorry. Need to squeeze in everything here. I need to have a bigger space over here. So this one, I write a bit in front. Keep the left, differentiate the right, plus keep the right, differentiate the left. Then differentiate the last one, negative t, differentiate, you get the negative 1. Multiply by this, multiply by dt dx is actually same as a divide dx dt. So because of the space constraint, I will just put it as divided by the dx dt. Okay, so now I just need to simplify it. So over here, you can see that this denominator over here, the whole thing, I going to multiply everyone by, it's the same as multiply everyone by square root of 1 minus t squared. It's the same. But because of space constraint, I didn't write it like that. Then straight away, this one can cancel, actually. So you can get this as a negative square root of 1 minus t squared. Then this one, this part you can simplify. Okay, this part, if you simplify it properly, if you simplify it carefully, then you will get this one as the you will get this as a t cos of t. Okay, t cos of t, then minus the square root of 1 minus t squared. Okay, because these two can cancel. Okay, but these two can cancel. But however, I don't cancel it over here because it's quite confusing if I cancel them directly like this. So now I after simplify, you find out that these two are the same. They can combine together. So at the end, your answer will be negative 2 square root of 1 minus t squared minus a t cos of t. Just like that, done. So that will be the answer for number 3. Okay. So now we move on to the question number 4. Okay, question number 4. It is given that the n is greater or equal to 0. Your in is given as integrate sec power n x from 0 to ln 3. Now for the n greater or equal to 2, they want you to show this relationship. So very obvious, this question is belong to the reduction formulae. So what you need to do is to think about, figure out a way how to do the reduction formulae. But over here, they give you a hint that you can use differentiate sec x equals to negative tan x sec x, this result. This result is not in the formula booklet. That means they actually allow you to use the result that's stated here. So first of all, for these questions, in 0 to ln 3, how do you integrate? So you can see that here have n minus 2. Here have n minus 2. If we separate this n to become n minus 2 out, and then multiply by sec square, then you can see that these two combine together. If they combine together, you still get sec power n. Okay. Now, however, if you do it like this, then what should we need to do with this one? You need to aware that integrate sec square. You need to understand that integrate sec square, you can get tan x. You need to understand that we have this formula to be applied. Okay, so we will use integration by part over here to solve it. So this one I going to integrate. This one I going to differentiate. Okay, so if you know the connection, now for this one, the one that differentiate I copy out first. Then integrate sec square x, integrate, you get tan x. I direct write tan x. Okay, I will not going to show how to integrate this anymore. So this one is from 0 to ln 3 minus, if the one that you bring out just now, you differentiate it, n minus 2 sec n minus 3x. Then after that, you need to differentiate sec x. Sec x differentiate, you get negative tan and sec x. But not to forget, you need to integrate this one as well. So if we need to integrate this one, I straight away multiply. Space constraint. Actually, I now don't have enough space already. I need to rewrite again. A bit long, this one a bit long. So I need to make my writing smaller to gain more space. So this one is integrate 0 to ln 3. This one you differentiate, you will get sec to the power of n minus 3x. Differentiate sec, you will get sec x, or negative. I forgot the negative. Based on this part, based on this, you get negative tan x and sec x dx. Okay, still line up, please. Oops. Negative tan x sec x dx. But not to forget that you need to multiply here. So I make it become square. Okay. After I differentiate, I still need to multiply by the integrations of the sec square. So I get tan x. So I make it become tan square x. Yeah. So now, this one I put ln 3 inside, put ln 3 inside, put 0 inside, put 0 inside. We know that tan 0 is a 0, but it's just that we need to find out. Also over here, well, actually we're supposed to mention this earlier. Sec of ln 3. Maybe no need. Okay, we can write it down over here. We can have a sec ln 3 power of n minus 2 tan ln 3 minus a 0. Okay, so I put 0 inside, I get 0 over here. So the whole thing will become 0. Then this one got negative, right? This one also got negative, right? So negative will become positive. Okay, so now this will become positive. Integrate 0 to ln 3. Now I want to multiply this inside. Sec power n minus 3, make it become, okay, I think this one over here, it will be better if I factorize the n minus 2 out. 0 to ln 3, I have a sec power n minus 2x tan square x dx. Okay, so we need to settle this part. If you use your calculator, actually just use calculator directly. Press the sec ln 3. Sec ln 3, you will get the answer as 3 over 5. Then tan ln 3. Tan ln 3 also use calculator. You get 4 over 5. Then plus the n minus 2. Integrate 0 to ln 3. You make the tan square become, what is the hyperbolic identity for the tan square? So hyperbolic identity for tan square is 1 minus the sec square x dx. And if you expand it further, this in front here already settled. Just take down only. Now the second part over here, I just need to expand them, become sec power n minus 2x minus the sec of the nx power nx. So that means this is a 3 over 5 power n minus 2, 4 over 5 here, plus the n minus 2. This actually is considered as in minus 2. This is considered as in. Just like that. Okay. So in and in, in front here still have a in. So the in and in need to join together. We need to combine them together. So if you combine them together, then you will get this as the n minus 1 in is equal to this. Plus the n minus 2 of in minus 2. Okay. So is this what they want? Yes, they wanted to show this. Okay, so just shown. Okay, so over here, consider done already. Just say shown. Okay, so this will be the answer for the question number 4A. Okay, a bit long. So now we move on to the question of number B, 4B. Okay, so now the questions want you to find I4. So just use a formula from part A. When n is equal to 4, from the formula in the part A, change the n become 4. You have 3I4 equals to 3 over 5 power 2, 4 over 5 plus the 2 of I2. Okay. So I need to find I4. So to find I4, I need to find I2. So I need to find I2 first. Then I only can finalize my I4. So when n equal to 2, so 2, use the formula again. It will be 1I2 3 over 5 power of 0 4 over 5 plus the of 0. Okay, plus a 0. Yeah, correct. So over here, your I2 is actually only 4 over 5. I call this one equation 1. I call this one equation 2. So 2 into 1. So my 3I4 is equals to the 3 over 5 square 4 over 5 plus the 4 over 5. Use your calculator, simplify everything. Your I4 will equals to the 236 over the 375. The question didn't mention the value of I4 should be in exact value or decimal, but usually we just leave the answer as fractions will do. Okay, so this answer will be I4 equal to 236 over 375, just like that. Done. Okay, so now we move on to the question number 5. Okay, question number 5. You have a diagram here, shows a curve with the equations of y equal to 2x minus x squared, where the x is from 0 to 1, together with a set of n rectangles with a width of 1 over n. They want you to consider the relationship over here to show that the un look like this. Okay, so this one, that means we want the area of the under the curve is less than the area of triangle. This is the area of triangle. Area of triangle, the sum of the rectangle, not triangle, rectangle. Okay, so this is integration. Okay, this is integration. So, okay. So you can see that first of all, we let our function equal to 2x minus x squared. Then our area of rectangle, if we integrate this is the area under the graph, is actually less than the f1 over n multiply 1 over n plus the f2 over n multiply 1 over n plus until n over n multiply 1 over n. Okay, so by right, you're supposed to have this. So from here, you can factorize the 1 over n out. The whole thing inside here can be written as fr over n, r from 1 until n. You can write like this. Okay, then remain this as 1 over n outside. Now you just replace all your x over here become 1 over n. Then you will get this relationship. You will get 2r over n minus the r over n squared. So the r is variable, n is a constant. So we just need to do the separable, separate them, you get this. Minus the 1 over n squared sum of the r squared. Okay, you separate them in such a way. Now you have two series over here. These two, you can just get it from the formula booklet MF19 to check what is the formula for the sum of the r and the sum of the r squared. So over here, sum of the r is n plus 1 over 2. Okay. Then the sum of the r squared, this one, it will be n plus 1, 2 n plus 1 over 6. Expand, simplify. If you multiply this in, you will get oh, sorry, I missed out. This one is 2 over n. I missed out 1 over n. So over here, there's a 2n here. So if you cancel the 2, cancel the n, multiply in, you will get n plus 1 over n minus the this and n cancel. You have a n plus 1, 2n plus 1 over the 6n squared. Okay. So over here, you can see that I have a n plus 1 over n is a common factor. You can factorize it out. So over here, you will get 2n plus 1 over the 6n. Okay. And if you join them together, this one, I split this, become n over 1 plus 1 over n. This one, if I join it together as a 1 fractions inside, it will be 4n minus 1. Then this is 1 plus 1 over n multiplied by 2 over 3 minus a 1 over 6n. Okay. So this is equals to the un shown. Okay. So that will be the answer for the question A. Just like that, done. So now we move on to the question B. So usually after you found the so-called upper bound, then the question wants you to use the similar method again to find the lower bound. So just now the upper bound, your area is great, the area rectangle is greater. Now this time you need to choose a lower rectangle. So this time I need to choose the lower rectangle here. I need to choose this rectangle. I need to choose this rectangle until the last one is here. Okay, so this is a 3 over n, this one is a 4 over n, and so on and so on. So now you just need to show that the integrate 0 to 1 of 2x minus x squared dx is greater than the f0 multiply 1 over n plus f1 over n multiply 1 over n plus until fn minus 1 over n multiply 1 over n. So as usual, we just make it become R over N. Your R start from 0 until N minus 1. So basically same as what we have just now. It's just that we start from different value and stop at a different value only. Okay, basically the idea is the same. So right here, you make this become R equal to 0. This one, it will be 2R over N minus the R square over the N square. Now, over here, if you want to use this formula, your R cannot start from 0. Your R needs to start from 1. So what you need to do now is I separate it. I put 0 inside. I put 0 inside. I put 0 inside. I get a 0. Okay, I get a 0. After I put a 0 inside, now I count from here as a 1. I start to count from here as a 1. Okay, start to count from here as a 1. Okay, so now we just repeat the process like just now already. This one is 1 over N, 2 over N of this time, because your last value is no longer N, your last value is N minus 1. So just use a formula from the formula booklet, MF19. So this one, it will be N minus 1, N over 2, minus the N minus 1, N and 2N minus 1 over 6. If you apply the formula from the formula booklet, MF19. So what you need to do now is just to expand and simplify as just now. Oh, sorry. Supposed to be like this. So this one, it will be N minus 1 over N minus the, oh, I forgot to put the N square. I forgot to put the N square here. Okay, so this one, it will be N minus 1, 2N minus 1 over the 6N square. So you can see that I can factorize the N minus 1 over N out. I have a 1 minus a 2N minus 1 over 6N. Separate it, N over N minus 1 over N. Join together, you have a 4N plus 1 over 6N. So at the end, you get this answer as 1 minus a 1 over N, 2 over 3 plus 1 over 6N. Okay, so this is the answer for your, this is the so-called LN. Okay, this is your answer for the B. Okay, so A and B done. Now we go for the last part, C. So that the limit of n goes to infinity of the un minus the ln, that will be equal to the limit of n goes to infinity of, what is a un? Un is a 1 plus 1 over n, 2 over 3 minus a 1 over 6n, minus the ln, 1 minus 1 over n, 2 over 3 minus the 1 over 6, plus the 1 over 6n. So when the n approaching to infinity, this will become 0, this will become 0, this will become 0, this will become 0, all will become 0 for this part. Okay? So when you express them out, you can straight away just write it like this. This is the 1 plus a 0, 2 over 3 minus a 0, minus a 1 minus a 0, and 2 over 3 plus a 0. If you make the n approaching to infinity. So at the end, you get the answer 2 over 3 minus 2 over 3. You get a 0. So that will be the answer for the question number 5. Number 5, part C. Okay, the number 5. All the question for number 5 done. Now we're moving on to the question number 6. Okay, now we take a look at question number 6A. show that the cos plus sine to the power of half is equal to e to the power of half x. So first of all, we start from the left-hand side. Since the expression is involving e to the power of half x, we will just use the definitions of cos e power x plus e to the power of negative x over 2. And then the sine is e to the power of x minus e to the power of negative x over 2, power half. So if you simplify them, you get only e power x power half. Therefore, you get e power half x. Shown. That is the answer for the part A. Then part B, they want you to find the particular solutions for the second order differential equations over here. So what you need to do is just take the left-hand side out. Let it equal to 0 first, and then convert them to become auxiliary equations. There will be m squared plus m plus 3 equal to 0. We're not able to factorize it, so we'll be using the quadratic formula to solve it. Negative b plus minus of b squared minus of 4ac divided by 2a. That will give you negative half plus minus square root of 11 over 2x. Oh, sorry, this I, not x. So your complementary function, it will be e to the power of negative half x, a cos of square root 11 over 2x plus the b sine of square root of 11 over 2x. Okay, so this is the answer for the complementary function. Now we want to go for the particular integrals. For the particular integrals, you just need to let it yp. Because of your right-hand side, we know that this is a 5e to the power of half x based on the part A result. So that means this is an exponential function. Exponential function, that means we just make this become pe power half x. Then from here, we find the yp prime and the yp double prime. Okay, so this is the yp double prime. Then after you found this, substitute them inside the second order differential equation. That will be yp double prime plus yp prime plus 3yp is equal to the 5 cos x plus the sine x power half. We already know that this is e power half x. Just change it to this way. This is a b over 4 e power half x. This is a b over 2 e power half x. And this one will be 3p e power half x. So you can see all the e power half x can be cancelled because they are not equal to 0. Cancel, 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 cancel. So at the end, you get this one as a 15 over 4p equal to 5. That will give you the p is equals to the 4 over 3. So your particular integrals will be 4 over 3 e power half x. So now your y is equals to the yc plus yp. That will be e to the power of negative half x, a cos square root of 11 over 2x plus the b sine square root of 11 over 2x plus the yp. Okay, so this will be the answer for the y. But this is the general solutions. The question is looking for particular solutions. Okay, so for the particular solutions, oops, this is a no negative. I make a mistake. The question is looking for particular solutions because they're giving you the initial value. So we just need to make use of this initial value to get the particular solution. So they're giving you that when x equal to 0, your y is equal to 1. X equal to 0, y is equal to 1. Okay, so we just replace it inside. So you get a 1 is equal to the 1 of A plus the 0 plus the 4 over 3. It will give you A is equals to the negative 1 over 3. Done. Then we need to find dy dx. From here, we find the dy dx. So to find the dy dx, this one will be a bit troublesome. Keep the left, differentiate the right. Plus, keep the right. Differentiate the left. Then after that, you differentiate this. You get 2 over 3e power 1 over 2x. Well, luckily, we just need to do until first derivative, no need to do second derivative. So I don't plan to simplify them anymore. I just need to substitute the initial value. When the x equal to 0, what will be your dy dx? Your dy dx is 4 over 3. So from here, just change it to become 4 over 3 is equal to the 1 of negative cert. This is a cert 11 over 2b. Okay, the a becomes 0 already. I mean, this part already becomes 0 because of sine 0 is a 0. Then over here, you have this as the a plus 0 negative half plus the 2 over 3. So we already know that a is a negative 1 over 3. So if you press a calculator, then you will get 2 over cert 11 of 2 over 3 minus a 1 over 6. So multiply together, 4, 1 over 6, 2 over 3, 4, minus 1, 3 over 6 half. Okay, so this one is the 1 over cert 11. B is 1 over cert 11. Okay, so therefore, we have found the a and b. Your y is equal to e to the power of negative half x. Your a is negative 1 over 3. Cos cert 11 over 2x. Your b is a 1 over cert 11. Sine cert 11 over 2x plus your particular integrals, 4 over 3 e power half x. Done. So this is the answer for the question number 6b. Okay, moving on, we have question number 7. Okay, moving on, we have question number 7. Okay, now we take a look at question number 7. Use a substitution u equal to 1 plus x squared to integrate this. So we just need to start from the substitution as given, 1 plus x squared. So your du dx will be 2x. So your x dx will be the half du. So from the integrations over here, you can see that you have a x dx here. Your x dx is going to replace it to become a half du. So it's just going to become a half du divided by the square root of u. So to integrate this, it's actually integrate half of u to the power of negative half du. Integrate this directly, you get a u power half plus c. Change your u back to the x, 1 plus x squared. Then you get the answer. So this is the answer for the number 7a. Then number 7b. Use the solutions of, find the solutions of the differential equations over here. This is the first order differential equations. They want you to find the particular solution, because and then in the form of y equal to fx. Okay, so what you need to do is that at first you divide the equation with x, and you get this. So from here you can see that this is a linear differential equations. So you need to find the integrating factor if, e to the power of integrate negative 1 over x dx. So it will be e to the power of negative ln x. It will be e to the power of ln of 1 over x. Just change it become 1 over x. That is your if. So if you multiply I call this one equation 1. From the equation 1, I multiply by the if. Then I get 1 over x dy dx minus the 1 over x squared. Y is equal to the arcsine of x. So now after you multiply the if, just take the if multiply y. Then you integrate your right hand side. Will do. Just integrate your right hand side like this will do. So your right hand side, you need to use integration by part to integrate it. Okay. So this is the okay, so you integrate by part, it will be x arcsine of x, because this one is considered as multiply 1. Integrate 1, you will get x. Okay, minus the integrate. This one is 1 over square root of 1 plus x squared multiply x. Okay, then you have x arcsine of x minus the integrate x of square root of 1 plus x squared dx. So from part A, we already know the result from part A. The result for this one, it will be square root of 1 plus x squared plus c. So your y is equal to the x squared arcsine of x minus the x 1 plus x squared plus the cx. Now we need to find the c. Okay, because what we have over here is the so-called general solutions, because they're giving you the initial value when x equal to 1, y equal to 1. So we can use this to find the c. When x is a 1, your y is a 1. Okay, then you just put a 1 here. 1 equal to the arcsine of 1 minus a 2 plus a c. So your c is a 1 plus a 2 minus the arcsine of 1. Arcsine of 1, the question didn't specifically mention that anything about the form. I think we will usually make it become the logarithm form. So logarithm form, just use a formula booklet MF19. You can get the answer will be like this. This is c. So once you found the c, therefore your y is equal to the x squared arcsine of x minus the x square root of 1 plus x squared plus the cx. So your c will be like this. Okay, so this will be your answer for the question number 7. B. Okay, so moving on, we have question number 8. A. Find the set of value A for which the system of equation has a unique solution. So we know that in order to have a unique solutions, the matrix over here is not supposed to be equal to 0. So we just need to take this matrix out. And not equal to 0. So to find the determinant, it will be 6 of negative 4 minus a 0, negative a of 10 plus 1 plus 0 is not equal to 0. So over here, this one I make a mistake. It's not supposed to be 10. I multiply wrongly. So this one is 8 minus 0. Okay. So at the end, your A is not equals to the negative 3. Okay, done for the x A. Now we move on to the x B. Show that the system of equations in part A is consistent for all values of A. For all values of A. So it's just that if your A is equals to negative 3, or maybe we just say that not equal to negative 3, then because we already know that it has a unique solution, therefore it's consistent. Okay, so if A not equal to 3, then from part A, it has the system has a unique solution. It has a unique solution. So therefore it's consistent. Okay, so if it's A not equal to negative 3, we know it's consistent. So now if we just need to consider if A is equals to negative 3. So what happened? If A equal to negative 3, then this system just change your A become negative 3. You will, I make it become augmented matrix. I will have this as a 6 to 1, negative 3, negative 1, and 5, 0, 0, 4. Your value is 312. Okay, so right here, I just take the row number 1 minus the 3 times of row number 2. Just take the row number 1 minus the 3 times of row number 2. So you get this as a 0, 0, 0. All the first row has become 0. Like this. So now we can say that this one have infinite solution. Okay, we have infinite solution. Okay, so therefore it's still considered as consistent. So therefore, the system has a unique solution for all values of A. Just like that, done. Okay, so for these questions, you have proven that not equal to 1 and equal to 1, not equal to negative 3 and equal to negative 3, both you will have consistent. Okay, so now we move on to the question C. So they are giving you that the augmented this is the matrix given for A, and you can see that this upper triangle all 0. So your eigenvalue will be all the value in the diagonal here. This will be your eigenvalue. Okay. So over here, we just straight away write eigenvalue. Lambda is equal to 6, negative 1, and 4. First of all, just direct right now eigenvalue like this. Then after that, we need to find eigenvector. Okay. So to find eigenvector, when the lambda is a 6, to find eigenvector is I, J, K. So over here, you minus, and minus. Okay, so you will have 6 minus lambda. This one you have a negative 1 minus lambda. This one you will have 4 minus lambda. So if you change the value of the lambda here becomes 6. Okay, if you change the value of the lambda here becomes 6. Oops. This one is a negative 1. This is 4. So if you change it becomes 6. So the first row is not suitable to use it. It's only suitable for us to use the second row and the third row. So it will be 2, negative 7, 2, negative 7, 0, and 1, 5, negative 2. Do the cross product, then you get this one as a 14i plus the 4j plus the 17k. Okay. So your lambda equals to negative 1. When the lambda is a negative 1, change all the lambda here become negative 1. then you can see that only the first and the third are suitable, or the second and third are suitable. The first and second are the same. So I choose the first and the third. So the first, if you choose it, you will get a 0i. And this one is 0i. Then this one, the j, it's also a 0j. Then as for the no, j is not a 0j. I make a mistake. J is a 24 minus a 24j. Then as for the k, k is a oh, I make a mistake. This is a 155, not 154. Okay, so this one is 30. Okay, so you can take the 30 out, then you make it become 0, -1, 1. Okay, then when the lambda is equals to 4, when the lambda is equal to a 4, then this will become -4, -4, and -4. So for this case, actually, you can just pick any two, which is fine. So I will 4. I will just pick the first and the second row. First one, it will be a 2, 0, 0. The second one will be a 2, -5, and 0. So if you press the calculator, you can get a 0i plus a 0j minus a 10k. You can factorize a -10 out, you have a 0, 0, 1. Okay, so these are all the eigenvector. Okay, so therefore your P is equals to the 417. 0, -1, 1, and 0, 0, 1. Okay, that is a P. Then my diagonal matrix, the diagonal matrix, I call this diagonal matrix, maybe I call it a D1. It's not a D, yeah. Okay, I'm looking for D. Okay, the question looking for D, but the D looks a bit complicated over here. So what I found over here, we can only say that this is a D1, not a D, not an actual D yet. So the D1 will look like this. The D1 will be a 6, -1, 4, 0, 0, 0, 0, 0, 0 here. Okay, so this is what we have at the moment. Now, the question asking you to find the D. We have found the B, then the D will be a bit complicated because this is something not usual. Okay, so what you can do is that first of all, we let this 14a plus the 24i as a matrix called the B. Okay, so we know that the eigenvalue for the B, it will be the same as the eigenvalue for this over here. And if you multiply them, you will get 24 EI. IE lah. EI, IE same lah. Okay, so the B, assuming the B, the eigenvalue is mu. Okay, sorry, this is a B. So assuming that the eigenvalue for B is a mu, then your eigenvalue for A is a lambda, because we use lambda right just now. So we use lambda E lah. So you have this one as a 24. Okay. All of them have E, all of them have E, lambda E. The E all cancel. You get the mu is equal to the 14 lambda plus the 24. Okay. So, not enough place already. Okay, maybe I try to squeeze in everything here. Not enough place for me, so sorry. I need to erase this to put in the theory. But actually, the mark scheme, they just direct solve it. I think I need to explain more further for you all to understand better. So over here, I just let the B is equal to the 14A plus 24I. Okay, so if you multiply the eigenvalue, so like I mentioned, the mark scheme didn't explain so detailed. So I just write it over here. I have the equal to the 14AE plus the 224IE. So this one is actually mu E is equals to the 14 lambda E plus the 24E. Cancel the E, you get mu is equal to the 14 lambda plus the 24. Okay, that is a relationship. Okay, so we have a B square is equal to the B inverse. So first of all, our D2, it will be equals to the 24 D1 plus the 14I. Sorry, 14 D1 plus the 24I. Based on this relationship, okay. So this will become 14 times 6. 14 times 6. This will be a 108. This one, it will be a 10. This one will be a 80. So your D is actually a D2 square. So D2 square, if you square it, then you will get the answer as a 11664. This one is a 100. This one is a 6400. That is the answer for the question number 8C. And now we move on to the last questions. D. Use the characteristic equations A to show that this relationship holds, and the B is an integer for us to be determined. Okay, so from the characteristic equation, we have lambda, not lambda, 6 minus lambda, -1 minus lambda, and 4 minus a lambda equal to 0. We just need to expand them. Okay, so have to expand them carefully. So over here, if you expand them, you get a -6 minus a 6 lambda minus plus the lambda square. Then you have a 4 minus lambda equal to 0. Then you get a -24 minus 5 minus 20 lambda minus a 4 lambda square plus the 6 lambda plus the 5 lambda square minus a lambda cube. So at the end, you get a lambda cube 5. Wait, I make a mistake. Lambda square. Positive 6 lambda square. -5, positive 5 lambda square. Then this one, 4 lambda. 4 lambda square. Positive 4 lambda square. I make a mistake here, sorry. So this one is a -9 lambda square. Then you have a positive 14 lambda. then plus a 24. That is your characteristic equation. Then from Cayley-Hamilton theorem, Cayley-Hamilton theorem, you have a cube minus a 9a squared plus a 14a plus a 24i is equal to 0. And you can see that the 14a plus 24i is over here. We can make this become 14a plus the 24i is equals to the 9a squared minus the a cube. But the question wanted to square it. So if they want to square it, just put a square on both sides. You square both sides, you factorize the square out first, you get a 9i minus the a square. Then you square it. Okay. Then the a square, if you square it, you will get a to the power of 4. This one, it will be 9i minus the a square. But you can see the answer over here, they stated they want the a to be in front, the b behind. Okay. Oops, sorry. This one is cube. So when I take the square out, this is will be only power 1, no more square. So you can see that they want the a power 1 to be in front. Okay, they want this to be a positive a power 1. Okay, so what I need to do here is I need to actually factorize a negative out. Then the negative, after you square it, it will become positive. So therefore, your B is a negative 9. Okay, B is a negative 9. Okay, so the answer for the B is a negative 9. So that's all. Okay, so this is the answer for the question number 8. Okay, I think the part C is a bit complicated, but okay, we are done. So I'll see you in the next video. Bye-bye.